You don't exist. Take a perk and a token and see.
Create a clinometer from a protractor and household items. You will need a protractor, 8 inches of string, any small weights, glue, scissors, a straw, and a clear tape. After getting all the necessary materials, begin by getting your straw and taping it to the straight edge of the protractor. Then push the string through the hole and tie a large knot on the other side so it will fix in place. Finally, on the other side of the string, your choice of weight will be tied and the finished results will be a clinometer. Alright, so the first question asked us, what is a clinometer? Describe how to make one from a protractor and household items, and explain how to use it and why it works. A clinometer is a tool that is used to measure the angle of elevation in a right angle triangle. It is used to measure the height of tall structures such as trees and buildings which you cannot reach the top of. To use a clinometer, you will need 2 people, one for looking through the straw and the other for reading the degrees that the string will make with the protractor. The first person will look through the straw and find the top of the object. Then the second person will read the angle that results from it. The distance between the first person and the base of the tree and the distance from the ground to the eyes of the observer will also be measured. After doing so, you have the necessary measurements in order to formulate and solve for the height of the object that you are measuring. The clinometer works because it utilizes the principles of trigonometry to measure the angle of the slope. This, along with the measurements of the distance from the said object and the height from the ground to the eye of the observer, will create a triangle that can be used to measure the height of the object.
Now, if we look at question 2, it tells us to assume that the rocket goes straight up and down. Now, if a person is standing 100 feet away from the launch pad, how can we use a clinometer to determine the maximum height of the rocket? For this question, it asks us 2 parts. It tells us to give a formula for the height of the rocket in terms of the angle A measured by the clinometer. Then, it tells us to create a quick lookup chart that has the angles corresponding to 100 feet, 200 feet, 300 feet, and all going up to 1,000 feet. First, let's figure out how the clinometer can determine the height of the rocket. The clinometer can determine the height of the rocket by finding the angle of elevation. By holding the clinometer by the base uppermost and making sure the string or line hangs down vertically, one person will then look at the top of the tree and someone else will read off the angle made by the string. This angle that was measured will then be subtracted by 90, and if it is greater than 90, or subtracted from it if it is the opposite. This can be used to find the maximum height of the rocket, as it makes possible to calculate the height of the rocket, and since the rocket only goes straight up or down, the maximum height of the rocket after takeoff can be calculated. You can then plug in any angle for the formula below and calculate the maximum height of the rocket. The next step is to find the formula for the height of the rocket. The formula for the height of the rocket in terms of the angle A is tangent times A equals height divided by base. One example of this would be 100 feet, and as we can calculate to find the angle of elevation to be 45 degrees and solve for the equation, it turns out to be tangent times 45 degrees equals height divided by 100 feet. We multiply 100 on both sides to get 100 times tangent times 45 degrees, which equals height, and we put that into the calculator to get the height of the rocket. The formula for getting the angle of elevation is tangent equals height divided by base. For example, with 100 feet height, to find the angle of elevation, we just plug in tangent square root of -1 all times 100 divided by 100. We then plug this into the calculator to get our angle. For the second case, we'll suppose that the rocket doesn't go straight up, but perhaps takes a curved path. It then tells us to explain why one person alone with a clinometer can no longer determine the maximum height. Now, one person alone with a clinometer can no longer determine the maximum height because of the fact that the clinometers do not provide immediate results. This means that one cannot just obtain any values unless they look at the top of the rocket and record the values, which isn't instantaneous, making it almost impossible to determine the maximum height since the rocket doesn't go straight up or down. Since it is also not a right triangle, it is much harder to apply trig functions and formulas like previously done to determine the maximum height of a rocket. As the triangle shown above is not a right triangle and its ratios are all messed up.
Two people can determine the maximum height of the rocket in terms of the angle A and angle B. The formula for determining the maximum height of the rocket is tan times angle A equals height divided by base for clinometer A, while clinometer B is tan times angle B equals height divided by base. As an example, let's say that the base for clinometer A is 125 feet, so putting a random angle like 65 will return the height. Tan times 65 equals height divided by 125 equals 125 tan times 65, so the height will be 268.06 feet.
Just came to the booth and asked for a wheel. She never heard drill in Atlanta.